Welcome back everybody to linuxacademy.com. My name is Terry, and in today's course we continue our preparation for the Linux Foundation Certified System Administration exam. In today's video we're going to be talking about how to mount a file system automatically on boot. So if you have not already viewed the videos on partitioning a file system and formatting a file system, which also covers how to manually mount those file systems in a directory, then I suggest you do so now. If you're already familiar with those, we can go ahead and skip right to the good stuff. Now this particular process will be non-specific to any version or distribution of Linux. In fact, everything we're going to do will work regardless of utility installation or anything else installed on any version or distribution of Linux. So we're only going to be talking about ways of doing this that will work across all distributions. So let's take a look at what we currently have on our file system. We can do a df-h, and we see that we have the SDA1 and SDA3 file systems available to us that are currently mounted. If we use the fdisk command, we can do a sudo fdisk-l, which will tell us that we also have an SDB1 and an SDC1 and 2 partition that at this point we know is formatted. We've done it in the past, but if you're unsure, then you can try to mount those partitions in a particular directory. In the /mnt directory, we've already created disk B1 for the SDB1 partition, C1 and C2 for the two partitions on that physical disk. And we could mount them from here by passing the proper parameters. However, we know that the root file system as well as the swap partition is mounted for us on system start. How can we get that for these particular partitions as well? Well, let's take a look at the etc fstab file. So if we do a sudo vi or vim on fstab, we'll see that the fstab takes something called a UUID, passes in the mount point, the file system type, and specific options depending on what it is in mounting these file systems. And then it has some special file systems that we're not going to talk about in any depth here. These are the three that we're talking about because these are representative of the SDA 1, 2, and 3 partitions, where we know SDA 1 and 3 are actually the ext4 partitions, and SDA 2 is the swap partition. But where did these UUIDs come from? Why don't they say just dev SDA 1, 2, or 3? Well, there's a good reason for that. UUID stands for Universally Unique Identifier. It's a method of, much like a MAC address is a unique identification of a particular NIC card in a system, it's a way of being sure that you uniquely identify a drive even if the drive letter or the partition number changes. And that's the main advantage, because I can refer to a drive and associate it with a mount point based on this UUID, whereas depending on what I do to my system, if you look here, dev SDA 3 or 1, those might change. If I, for example, pull that drive and plug it into one of the other ports in my system, that may change that drive to SDB2 or SDC2. So in other words, the UUID gives me a way, despite changing configuration of my storage subsystem, to be able to identify what a drive is associated with. Well, how can I get those IDs? The good news is that UUIDs are automatically created anytime a file system is added to a system. And the only way to get it specifically for every distribution is to look in the file system. And now if you've been following along with our course, you know that Linux treats everything, whether it's a file, a folder, or a physical device, as a file. So I should be able to look at, in the appropriate device directory, a reference to the UUIDs on my system. And indeed I can. So if I go to the /dev/disk directory, there's a directory in here called by UUID. So if I go to by UUID and I do an LL here, it will tell me that my SDA1 drive is associated with this UUID. So for example, I want to add the boot for SDB1 with this UUID to my system as appropriate. So let's copy this. Let's go to the mount directory, make sure that we understand that disk B1 is where we're going to add the mount point for it. And then we'll do a sudo vim etc fstab. Now all we're going to do is insert a line, and I'm going to comment this here, referred to as the original dev SDB1. That's just a note for me so that I understand what that is. I'm going to say UUID, and here's where I'm pasting this in for obvious reasons. Then I'm going to say that that is going to be mounted to disk B1. It is an ext4 partition. I will simply use the default mounts here, so I'm not going to do anything special. And I'm simply going to use the default mount type of 1.1. Now here's one of the advantages to doing that. If I save this file, when I reboot disk dev SDB1 with that particular UUID, will be mounted to mount disk B1. However, now that it's in the fstab file, then what I can do is I can mount that drive by name. So I should now just be able to say sudo mount disk B1. And now if I do a df-h, I show that dev SDB1 has been mounted, and that's because it reads the fstab file to look for references to something that it knows how to mount. And because I've added the SDB1 drive with that specific mount to it, when I asked it to mount that mount directory, it was able to scan the fstab file and find out that it should be mounted as dev SDB1, because that UUID is what's physically associated with that SDB1 partition. Now let's go ahead and unmount this just real quickly, and we'll look at one other thing. So once I've got that unmounted, I've got a file system here, for example, that only has SDA1 and 3 mounted, and I know SDB1 and perhaps other file systems need to be mounted. For whatever reason, they weren't mounted on boot. I can simply tell the system to scan and mount anything that it knows how to mount from the fstab file by simply doing a sudo mount -a. That will read that file. Anything that's already mounted, it'll ignore. But now we can look and see that now dev SDB1 is once again mounted. And we can do the same thing as long as we know what those UUIDs are. We can do the same thing for SDC1 and SDC2. And again, the reason that we use UUID is because in a changing system configuration, I can completely change the lettering, the ports, and everything associated with my disk subsystem. But the important thing is my UUIDs are never going to change. So as long as I mount by UUID, I don't have to worry about ending up with a system that's unbootable after I make changes to my storage subsystem. So that's all there is to mounting disks automatically on start. My name is Terry for Linux Academy.